All right, let's move on to question number 5. So question number 5 reads, what is the limit as x approaches infinity of e to the x, of function e to the x, okay? So they're basically asking us, if we write in conventional notation, what is the limit? So this is the limits notation when x approaches infinity of our function e to the x. So essentially, they want to know, the question is asking us for the end behavior of this function as x approaches infinity. So if you were to graph this out, right, e to the x kind of looks like, I'm just going to draw it like this, e to x kind of looks like that, right? So they want to know what happens when x approaches infinity, right? What is the value of our function as x approaches infinity, right? So there's a lot of different strategies calculating limits. You can use conjugates, you can use algebra, you can also use some logic to figure out the limit. But the most simplest method of figuring out a limit is to just plug in the value that it's approaching to. So in this case, when we're calculating the limit of e to the x is approaching infinity, so we're going to say we're just going to plug in e to the infinity. And infinity is just a huge positive number, right? And since we know e will always be positive because it's a positive base, we know that anything to the power of a huge big number is going to be pretty big itself. So we're just going to say it's a pretty big number, which is infinity, right? So the most simplest method of calculating limits is just by plugging in whatever the approaching number value is, right? And in this case, as we substitute infinity into our function, we get infinity. So now we know that the limit approaches infinity the function approaches infinity as x approaches infinity. Okay. So the junior tutor also provided that kind of solution. They didn't give the graph, but they reasoned that Euler's number is 2.71828, blah, 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 which is always going to be positive, right? And a number that, a positive number to the power of another positive number is always going to be positive. So the reason that, okay, this exponent is going to be really huge, the value of this exponent is going to be really huge, so we're just going to say it's infinity, and that's why we know that this function, as x approaches infinity, is going to be infinity. So the solution is correct. Cool.